In this video, we're going to be looking at inequalities. We'll look at solving them. We'll look at using them to express the domain of a function, and we'll look at some worded problems. To begin with, an inequality is any mathematical statement that uses these symbols down below. So this is less than, greater than, less than or equal to, or greater than or equal to. Some people have learned how to point the thing in the smallest toward the smallest thing, and that'll help you a little bit, but you really should be able to look at that and say that's less than, or look at that and say that's greater than or equal to. Okay, when we're solving a linear inequality, you use the same principles, addition, subtraction principles, as you always do. The only caveat when you're doing the multiplication division principle, that if you multiply or divide an inequality by a negative number, you have to switch an inequality from whatever it is to the opposite one. So instead of less than, you'd have to switch it to greater than. Try some questions. So here's a nice simple inequality to solve, and I want to solve for x. In other words, at the bottom I want to have an x there, a greater than, and then some kind of a number. So I've got to move some things around. The first thing I'll do is I'll add 3 to both sides. So I'll have 5x left on this side is greater than 7 plus 3 is 10. And then I'll divide both sides by 5. Notice I didn't divide by a negative number, I just divided by a positive, so this symbol can stay where it's at. The 5's cancel, I'm left with x is greater than 2. So that would be my solution for that question. Now that's sort of like in set notation. You could write it as the answer, all the x's, as long as x is greater than 2. It's useful to write it also in interval notation. So again, I like to use a number line. So here's 2, and my answers are x are greater than 2, so it's all the numbers this way. Since it's not equal to, then I would use this kind of symbol in my number line, and I'd use that same symbol when I do the interval notation. So the smallest number is 2, the biggest number is forever or infinity, and this bracket gets a curl bracket, a normal one, as does infinity. Here's another one to try, and maybe you want to try it on your own and then press pause and then press play and see if I get it right or if you get it right. Okay, so I would probably subtract 8x on both sides, and then I'd add 9 on both sides. So I'd be getting 4x on this left side is greater than or equal to 7 plus 9 is 16. Then I'll divide both sides by 4. Again, I didn't divide by a negative, so the inequality stays, and I come up with 4. Number line, 4 is here. It's everything that's bigger than that, but it can include 4, so I put a square bracket there. In interval notation, it would be the smallest numbers are 4, biggest numbers infinity. Okay, and it can include 4, that's why the square bracket. Okay, here's another one. This one involves some brackets. We can deal with those. Less than or equal to, let's use the distributive property, 5x minus 15. Then let's do the same thing as we did before. We'll subtract 5x here and subtract 5x there. Here I'll subtract 4 and I'll subtract 4. So on the left side I'll get a negative 2x is less than or equal to. These cancel, this would be a negative 19. Now to solve this one, I'm going to have to divide both sides by a negative 2. So when I divide by a negative 2, the 2's cancel and the negative does. And so I'll get an x. On the right side I'll have a positive 19 over 2. But because I divided by a negative, that symbol there's got to change from less than or equal to greater than or equal to 19 over 2. Now, some of you might be thinking, well, why don't we, instead of moving things to the left side, let's keep things on the right side. I'll just start here. And so maybe I can subtract 3x on this side. So I'm getting my x's on the right, and I'll add 15 on this side, add 15 on that side. So these cancel, these cancel. I'm left with 19 is less than or equal to 2x. So notice here, I don't have to divide by a negative, so I don't switch the sign. So if I divide both sides by 2, I get 19 over 2 is less than or equal to x. And if you take a look at that solution and this solution, hopefully you can see they're the same thing. In this case, 19 over 2 is less than the answers. In this case, x is greater than 19 over 2. So they both mean the same thing. If you want, you could take this as a solution, and since we typically write x's on the left-hand side, you can move the x to that side and the 19 over 2 to the right side. But if you swap them like that with an inequality, you just have to switch the inequality. And notice now they're the same thing. Okay? All right, I could prove that another way too, but hopefully that suffices for now. One thing that we often use inequalities for is expressing domains of functions, specifically domains that might have a range of numbers that would work. I guess that's what a domain is. But this is a case where I've got a range of numbers that don't work. So if I have a square root function, like this one is, there's one thing under the real numbers, we don't allow a negative number under the square root. We can deal with those with complex numbers, but not with real numbers. And so if I say what's the domain under the real number system for this function, I'd have to say like a number like 2 wouldn't work, because 2 take away 4 would be the square root of negative 2, and that doesn't work. Like that's not part of our domain. So 2 won't work as a solution. 3 take away 4, that gives me a negative number as well. But 4 would work because 4 take away 4 is 0, and the square root of 0 is 0. So 4 would be the first number that would work. So in terms of an inequality, the way you could express that is you can say, well, your answers for x must be 4, so it can be equal to 4, or any number that's greater than 4. So you could use an inequality to express the domain of that function. So x is greater than or equal to 4. Again, you could do number line and interval notation. So x is greater than or equal to 4, so 4 would be the smallest number it could be. Infinity would be the largest. And notice that I put the wrong comma there, or the wrong bracket. Because it can be equal, I should put a square bracket there. But this is what they're trying to show from that question. Okay, here's a couple of examples of inequality and applications. A job offer one is a typical one. So suppose that Isa was offered 2 contracts. Contract, that should be A, pays $400 plus $15 for every hour that you work. But contract B is only $25 per hour. So the question says, after how many hours will contract B pay more? Okay, so I can say, I want to know when A is less than B. In other words, B is greater than A. Okay, so that's the inequality I want. So I look up at A, and A, you get $400 just for showing up, plus you get $15 for every hour that you work. We'll use X for hours. Okay, is less than, when is that contract A less than B, which is just $25 an hour. 25X, 25 times the number of hours. Okay, to solve this, I'm going to subtract 25X on both sides, and I'm going to subtract 400 on both sides. So these cancel, and this will be a negative 10X. And then these cancel, and this will be less than negative 400. So when I divide both sides by negative 10, notice what's going to happen to the inequality. These will cancel, so I'll get X. This has to change, so it'll be greater than. Negative 400 divided by negative 10 is 40. So for contract B to pay better than contract A, you've got to work 40 hours. Let's just test that and see what happens. So contract A is 400 plus 15x. Let's say, let's use x is 40. So 400 plus 15 times 40. 15 times 40, I think it'd be 600. And so if you work 40 hours, you're going to get paid $1,000 for contract A. For contract B, you're just 25 times the number of hours you work. And 25 times 40 is 1,000. So if you work 40 hours, it's going to be the same. But as soon as you work more than 40 hours, so 40.1, or you could say 41. So if I were, and you can try that, put a 41 in there and a 41 in there, and just figure out what it comes out to, and you'll find that job B will pay more for anything over 40. Okay, another similar kind of question. It says, for one plan, telephone company, they charge you $60 a month and 15 cents a minute. And then they say, how many minutes can people on that plan use and still stay under $100 for the month? So I have to pay $60 plus I have to pay 15 cents for every minute. For minute, let's use X. And I want to know when that is less than $100. Okay, to solve, let's subtract 60 on both sides. So I get 0.15x is less than 40. And then I'll divide both sides by 0.15. Divide by 0.15. So I get x is less than, and then whatever 40 divided by 0.15 is. I don't know what that would be. Let me check. Okay, it comes out to 266.6, etc. minutes. Okay, so if you want to stay under $100, make sure you stay under 266 minutes of talk time. So in this video, we've looked at solving, or what a linear equation is and how to solve them, how to identify a domain of a radical function, and we've also solved a couple problems. Okay, so try the quiz and try the homework.